Alright guys, we're going to talk about the review. Alright, so this is problem 1. Okay, so it says 8 minus 3 raised to the x is equal to negative 1. We want to solve for x. X is currently the exponential position. Okay, so that means we need to get this base 3 to the x. We need to get this guy by itself. We need to get this part right here. We need to get this by itself, and then we're going to switch to a logarithmic function. Okay, so in order to get the 3 raised to the x by itself, I'm going to start off by subtracting 8 on both sides. Alright, so now I have negative 3 raised to the x is equal to negative 1 minus 8, which is negative 9. Divide by negative 1 on both sides. And that gives me 3 raised to the x is equal to a positive 9. Okay. And now I have the base by itself, 3 to the x. Okay, so I'll change it to a log. Log base 3 of 9 is equal to x. Awesome. You type this part in the calculator, you're going to get 2. So 2 equals x. And that's how you do problem 1. Let's move on to problem 2. Okay, problem 2 says log x minus log 3 equals 2. Alright? So the first thing I'd like to point out here is that the understood base is the number 10. Alright? Since there's not a base written, the base is understood to be 10. Okay? The next thing I want to point out is that you have 2 logs subtracting. Okay? Since you have 2 logs subtracting, you can make that 1 log, but now the inside guys are dividing. So we can now say x over 3 is equal to 2. Okay? So when you're looking at this, hopefully you realize, oh, this x is trapped by the logarithmic function. So I need to remove the logarithmic function. You can remove the logarithmic function by taking the base. So what is the base when all you see is log? When there's no base written, the base is understood to be 10. So you can say 10 raised to this guy over here, to the 2, is equal to x divided by 3. Okay? 10 squared is just 100. X divided by 3. You want to get just x, so you need to multiply by 3 on both sides. And so that gives you 300, because 10 squared is 100. 3 times 100 is 300. And that's problem 2. Alright? So let's move on to problem 3. That's probably our hardest problem on this entire paper. Alright, we're on problem 3. Natural log of x plus natural log of x minus 2 is equal to the natural log of x plus 4. That's a parenthesis. I just apparently forgot to finish it. Alright, there we go. Okay, so a couple things to point out about this problem. One, there's a whole lot of natural logs. What is the base when it's a natural log? That's right, the base is e, the number e. Okay, now another thing I want to point out is you have 2 natural logs adding, so you can make this one natural log where now they are multiplying. Okay, equal to the natural log of x plus 4. Okay, so what we're actually going to do is multiply this x into this x minus 2. So that gives me the natural log of x squared minus 2x is equal to the natural log of x plus 4. Okay. Remember, just because I went x times x times negative 2. That's how I got this part right here. Okay. So what I'd like to point out here is that you have the natural log of x squared minus 2x equals the natural log of x plus 4. So both sides have a natural log. Your goal is to make them equal. So that means basically all you care about is getting the insides of these parentheses equal for this particular problem. Okay, this just takes a little bit of logical thinking to realize, oh, these are both natural logs on either side, so I just need to make them equal, so I just need to make their insides equal. So basically, for this specific problem, I can ignore the natural logs and just set these pieces equal to each other. Okay, so now I have x squared minus 2x is equal to x plus 4. What kind of equation do I have right here? Hopefully your brain is screaming quadratic, quadratic, quadratic. Okay, and that means you need to make it equal 0. Okay, anytime we have a quadratic equation, you need to make it equal 0. So that means I subtract x plus 4 from both sides. So I say negative x minus 4. So I get x squared minus 3x minus 4 equals 0. And now, hopefully, like, oh, that's right, now I need to factor this. And I can factor it through tic-tac-toe or any other method I know, okay? Or I could use the quadratic formula. I'm not particular, okay? So we put x squared right here We put negative 4 right here. Multiply the 2. That gives us negative 4x squared. We add to be negative 3x. Okay, so I need to find two numbers that multiply to this, but add to this. Well, hopefully like, oh yeah, that's pretty obvious. Negative 4x and positive x. That would multiply negative 4x squared, and it would add to be negative 3x. Now, what does x squared and negative 4x have in common? X. What does x squared and x have in common? X. X times what is negative 4x? Negative 4. X times what is x? 1. Go across, go across. So we can rewrite x squared minus 3x minus 4 into being x minus 4 times x plus 1. And now what we can do is we can take each parenthesis and we can set each parenthesis equal to 0. So I can say x minus 4 equals 0. And I can say x plus 1 equals 0. And I can solve for x on both of them. So on this first one, x minus 4 equals 0, I'd add 4 to both sides, so I'd get x equals 4. On this one over here, x plus 1 equals 0. I would subtract 1 on both sides, so I would get x equals negative 1. Boom, I have my two answers. But it's important to remember something. What can you not take the log of? I know this is a natural log, but you're taking the natural log of x. What can you not take the log of? Negative numbers. So if you were to let x be negative 1, which there's nothing wrong with x being negative, okay? But if x was negative 1, you came up here and plugged it in, you would be taking the natural log of negative 1. Well, wait, that would be trying to take the natural log of a negative number. Are you allowed to do that? No. So that means this answer is called an extraneous solution. It's bad. I don't use it. I don't include it. X equals 4 is the only answer I include. All right? Let's go on to problem number 4. Okay, question 4. E raised to 3x is equal to 20. So first, I would like to identify my base. It's just e, okay? You'll notice is the base already isolated? Yes, it is. So x is trapped in the exponent position. The base is isolated. So at this point in time, you're ready just to go from exponential form to logarithmic form. So we say a natural log. Now, why did I say natural log? Why did I not write out log? Because I know the base is going to be e. And I know logs that have base e are called natural logs. So I say the natural log of 20 is equal to 3x. Okay, so now I got to finish solving for x. So I simply divide by 3 on both sides. Divide by 3. It's going to equal x. So now I'm just going to type natural log of 20 divided by 3 into a calculator. Okay, so turn natural log of 20 divided by 3. Press enter, and I get 0.998. And then this 7 will bump this 5 up to a 6, so it's going to be 0.9986. And that is approximately what x is equal to. Make sure you realize I put a decimal here. Okay. I had this one over here, which is kind of hard to see. All right, and that's it. That's all there is to number 4. Okay. Number 5. Number 5 says, and I'm not even going to put the question up there, I'm just going to write the answer. But number 5 says, explain the difference between exponential growth and exponential decay. Growth simply means your base is bigger than 1. So all I would expect for a problem like this is that the base is bigger than 1. Decay simply means that your base is between 0 and 1. Bam. There's your exponential growth. There's your exponential decay. Okay? Let's go on to problem number 7. I meant problem 6. I said problem 7. Okay, problem 6. Now, a couple things to point out. One, all this question wants is the transformations. In other words, it just wants you to say if it's going up, down, left, right, vertical stretch, vertical compression, reflection. Okay, that's all it's looking for. Okay? So first, I want to point out that this 2 is being raised to the x power. So this means this is an exponential situation because x is in the exponent. Okay? So that means this base of 2 does nothing as far as transformations are concerned. Okay? The only thing that do transformations is this negative sign and this plus 1. This plus 1 is outside the function, so it means up 1. This negative is multiplying to the base, so it's a reflection across the x-axis. And bam, that's all you needed. That is all the transformations for problem 6, okay? Now let's go to problem 7. Problem 7, y equals 2 times e to the x minus 7. the base is e to the x. Okay, so the e to the x just tells me it's an exponential situation with base e. Okay, so then this 2 is multiplying to the base, so this is a vertical stretch by 2, and this minus 7 means down 7. That's down. Alright, down 7. And that's it. That's all the transformations for problem 7. Okay, let's go to problem 8. Okay, problem 8. The base is 5, so there's a plus 1 up here in the exponent with x, and there's a minus 2. Well, the minus 2 is outside the function, so it simply means down 2. Alright, this plus 1 is up here in the exponent with x, sorry. This plus 1 is up here in the exponent with x, so it means left 1. And bam, that's all the transformations this problem has. Alright, let's try going to another problem. Let's go to our next one. Okay, so when you look at this problem, natural log of x minus 2 plus 4. This minus 2 is with the x, so it means right 2. Okay, and this plus 4 is outside the function, so it just means up 4. So it just means up 4. And bam, that's all she wrote. Those are all the transformations for this problem. Okay, so let's go to our next problem. Okay, so this next problem says evaluate, okay? And it's log base 1/2 of 1/4. Guys, this is just plug in the calculator. Alright, so if you don't remember, I suggest writing it down, but this is how you do it, okay? You hit math, you scroll up to log base, where base is in big capital letters, B-A-S-E, okay? So log base, and when you click it on the calculator screen, comes up log, and then comes up a box here, and a box here. And then you just type it in appropriately, and you press enter, and you get 2. Alright, that's all there is to this problem, really, okay? Same thing with our next problem. Same thing with our next problem. You just type this guy in the calculator, and you get 6. There's just not a whole lot more I can talk to you about it than that, okay? Now, the reason we get 6 is because 3 raised to the 6th is 729, but that's all there is to this problem. Just type this part in the calculator. Alright? Let's go on to our next problem. Okay, problem 12. State which property or properties need to be used to write each expression as a single logarithm. Okay? So when you look at A, it says log base 6 of 16 minus log base 6 of 4. You have 2 logs subtracting. So that means you don't have to actually do this rewriting. I'm just doing it for your benefit. But that means you can actually rewrite it as 1 log, and since they were 2 logs subtracting with the same base, you can make it 1 log where now the inputs, the inside pieces, are dividing. So 16 over 4. Okay? And then if you actually were doing simplifying this problem, you could actually write this, which would then be 4. Okay? And bam, there you go. Alright? And so the question is, what is that property? That property name is called the quotient property. It just simply says that if you have 2 logs subtracting, you can turn them into 1 log dividing. Okay? Part B, alright, 2 log base 2 of 3 plus log base 2 of 4. Okay, so same idea. I basically want to condense basically, okay? But you see this 2 right here I have right here? That's outside the log. That's multiplying to the log. So you know what I can actually do? I can actually take it and make it an exponent inside. Again, you don't actually have to do this first part. All you have to do is write the property name, but I'm just trying to show you what would happen. So now that became 3 squared plus log base 2 of 4. Okay, now you have 2 logs adding with the same base, so you can rewrite them as 1 log, and you can make them multiplying. And then if you wanted to even go a step further, you could say log base 2. Alright, 3 squared is 9. 9 times 4 is 36. So log base 2 of 36. Okay? Now what properties of that? Well, there were 2 properties. There was one where I moved this 2 to become a power, so we call that the power property. And then there was the property where I took the 2 logs that were adding and made them 1 log multiplying, so we call that the product property. Alright? Let's move on to our next question. Question number 13. Alright, question 13 says rewrite each into logarithmic form. So right now this is exponential form. It wants me to rewrite as logarithmic form, okay? So first off, if you want to write log form, start off just by writing log. Then take the base 2/3. It stays the base, so log base 2/3 of, we take the 27 over 8, and that becomes our input, of 27 over 8 is equal to negative 3. Bam. That's all there is to it. It's that simple. Okay? Let's go on. Let's try problem 14. Problem 14 is the same type of question. I want you to take this exponential form and rewrite into log form. So you just say log base 2 of 0.0625 is equal to your exponent, which is just negative 4. And bam, you're done. That's all there is to it. That's it. That's the entire problem. It's that simple. Okay? It's really just that simple. All right, let's move on. Number 15. All right, number 15 says simplify each log expression. Okay? So basically, I just want to use those properties I talked about earlier to make bigger logs become smaller logs. Okay? So when you look here, log of 2 minus 3 log of 1. You'll notice that they both have base 10s because I don't see a base, so I can assume the base is 10. Secondly, you notice I have a 3 multiplying to the log. That means I can move this 3 inside to being in a power position. Alright, so log of 2 minus log of 1 to the third. Now, I like to go ahead and simplify what is 1 to the third. Well, that's just 1, right? Because 1 raised to the third power is just 1 times 1 times 1 times 1, and that's just 1. Now, you have 2 logs subtracting, so you can make that 1 log with the 2 inputs now dividing. And then I go ahead and simplify one step further. What is 2 divided by 1? That's just 2, right? So log of 2. Bam. That's all there is to it. That's all there is to problem 15. Okay, let's go to problem 16. All right, so problem 16. What I point out first in this problem is notice inside the parentheses, you have 2 logs that are adding. So you can make it 1 log where now the 2 inside pieces are multiplying. So it becomes x times z. Okay? And then what I would notice is that you have a number multiplying to the log. So that means that number can go in and become a power on x times z. But it needs to make sure it's going to both of them. So I recommend putting xz in parentheses and then putting in a power like this. But something else you could also do, because the x and the z should get the power of 1/3, what you could also do is say log base 4 of, and you could say x to the 1/3 and z to the 1/3. Alright? Either one of these answers to me would be appropriate answer choices. Alright? Let's go on to our next problem. Our next problem, problem 22. Now realize I skipped 17 because I told you guys not to worry about it in class, and for some reason you didn't hear me, don't worry about doing problem 17. Okay? Problem 22. Y equals 3 raised to the x plus 1. First thing you should notice, this guy is an exponential problem. Okay? So that means that we have a horizontal asymptote. Okay? You should just remember that. Okay? The horizontal asymptote is at y equals 0. However, this plus 1 is going to take that horizontal asymptote up 1. So now my horizontal asymptote is right here at the line y equals 1. The next thing to remember is that exponential usually crosses through the point 0, 1, but now it's going to cross, I have to move it up 1, so it's going to cross through the point 0, 2. And then you just kind of go do 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 do. Alright, so I'm sorry that my hand, and this really needs to be, alright, I got this again. That was just so bad. It's got to be coming closer to the asymptote. And the reason it's growing from left to right is because what is the base? The base is 3. 3 is bigger than 1, so it's an exponential growth. So it should look something like that. Remember, we sketch in this class. I would never say these graphs are extremely accurate. They are sketches, rough sketches even, just to make sure you have the idea of what's going on. Okay? Let's move on to problem 23. Problem 23 says y equals log base 5 of x. Okay, so this is a log problem. Okay? So that means I have a vertical asymptote at x equals 0. There's no transformations, so that vertical asymptote will just stay on the line x equals 0. Alright, so x equals 0. Alright, that's my vertical asymptote. Then I go through the crossing point of 1, 0. And the base is 5, that's bigger than 1. So this is a logarithmic growth, so it's just going to look something like that. And there you go. Alright, let's go to problem 24. Problem 24 says y equals log of x plus 1. So 1, the understood base here is 10. That's going to be important. Okay. But there is a transformation. There's a plus 1 transformation, which means my graph has moved to the left 1 unit. So instead of having a vertical asymptote at x equals 0, I now have a vertical asymptote at x equals negative 1. Okay, so I draw that. That's always the first thing I like to draw. So x equals -1. Then I usually cross through the point 1, 0, but since I moved to the left 1, I won't be crossing through the point 1, 0. I'll be crossing through the point 0, 0. The base is 10, so that's a growth. So it means I'm going to come up and over. Okay, that's 24. Let's move on to problem 25. Problem 25 has two transformations. So first off, this is log base what looks to be 6. Hold on, let me double check this. No, I'm sorry. That looks like it's a base e. I don't know why we wrote log. We definitely should have put ln. If that is base e, we most definitely should have put ln. That is a mistake on our part. I'm just double checking it real fast by zooming in. Yes, that is a mistake. That should be ln, okay? You never write log of base e. You write ln because that's what it stands for, okay? Anyway, so I'm glad I caught that to talk to y'all about that. So, now we're going to go back to this problem. So, natural log of x plus 3 minus 6, okay? Even though it's natural log, even though it's base e, we still do it the same way. There's still vertical asymptote x equals 0, but there are some transformations that are going to change that, okay? Such as this left 3 is going to take this vertical asymptote back 3. Now let me ask you, if you already have an infinitely long up and down line, is moving 6 down going to actually move that infinitely long up and down line at all? No, it's still going to be infinitely long up and down. So you're still going to have something that looks like this. Okay, so there's my vertical asymptote. Now my starting point for logarithmic is usually 1, 0, but I need to move to the left 3 and then down 6. So there's my new starting point. Since my base is e, e is bigger than 1, so that is growth. So it's going to look something like this. Alright, so there we go. Alright, problem 26. Problem 26. You put $2,000 into an account earning 4% interest compounded annually. Find the amount in the account at the end of 8 years. Okay, this is just where we're using that formula. Y equals, or maybe you want to say P equals, because that stands for principal. P equals A, and principal by principal amount is how much money you have in there. Y equals A, which stands for your starting amount. Oh no, I'm writing this function wrong. My apologies. It should be A equals P. That principal stands for your starting amount, how much money you put in. That's the principal. 1 plus R raised to the T. Okay? So in this case, how much money did I put into the account? You know, at the very beginning of it, $2,000. How much money is it making every year? 4%. So that'd be 1 plus 0.04. How many years was it in there? 8 years. So we're just going to type all that jazz into a calculator and get our answer. So 2,000, 1, 2, 3, times 1 plus 0.04 raised to the 8th. Press enter, and we get 2737.14. So we would have dollar signs, 2737, I forgot what it was, 0.14, 0.14. Bam, there you go. That's how much money you would have after 8 years if you put $2,000 in it and didn't touch it. Alright guys, let me know if this video had any errors. Let me know if you have any questions. Feel free to send me an email. Feel free to send me a remind. Alright, have a good evening.